Hey guys, Rudy back again with part 2 of the week 3 tutorial video for CSSC 1001 and 7030. If you guys haven't seen part 1 for this, I'll chuck it in the description below and you should really watch that first. Otherwise, yeah, let's just keep going on with the tutorial. Okay, so let's look now at this interact function. Def interact, taking no arguments, which first asks the user for a distance, then repeatedly asks for a direction to move from the options N, S, E, W, and then moves in that direction by the given distance. If the user enters Q, the total window closes and the function ends. The user enters any other thing, an error message is printed. Okay, well let's just start off with what we've got here, which first asks the user for a distance. So whenever we're asking the user for something, remember that is the input function. So distance. Just to mirror exactly what they've got here. Now, remember, we don't just want to be sort of asking the user sort of what their input is and then not storing it anywhere, right? That's a bit pointless. We want to make sure that we store this somewhere in a variable. Okay, so this is our distance. And let's just check that this is, yep, so distance, boogly, boogly, boogly. Cool. And then nothing really happens, but we can see we spawned the total window and it's not doing anything, okay? Because we haven't told it to do anything yet. But we can see that we should be able to access our distance variable. Oh wait, no, sorry, the shell restarted. Excuse me. Well, that was a terrible example, but I guess we'll print this out in a second. Let's just make sure that we're getting our distance. Print distance 50, and it's printing out our 50, so we're good. Okay. So let's try and keep going with this. What did we want next? Repeatedly asks for a direction to move from the options N, S, E, W, and then also a Q, and some stuff's going to happen every time we do that. Okay. So we then want to get some more input from the user on a direction. So let's get direction. Direction. Okay. And then basically, depending on what this direction is, we need to move our turtle north, east, south, west, or quit. Okay? So essentially, we've got a couple of options here. We've got N, S, E, W, Q. And I guess what we're going to want to do here is have a look at a bunch of sort of options here with our if statements. So if direction equals north, then we want to move our turtle north. Right? Now, regardless of which way he's facing, we want to be moving north. So we're gonna want to use that set heading guy we had from before, right? So 0 is east, 90 is north, 180 is west, 270 is south. Okay, so normal sort of mathematics. So if we want to make our turtle go north, we're gonna have to set his direction to north, which was 90. Okay, and then we are going to want to move forward with our turtle. Now, how far are we going to move forward? We're going to move forward this distance guy. Okay. And yeah, so let's just do a quick dummy check with this. So here's our turtle. Distance 30, direction north. Ooh, what do we got here? Module turtle has no attribute set direction. Oh, what was it? Was it set heading or something? Set heading. Okay, my bad. Set heading. Okay, distance 30, direction north. Type error. Can't multiply sequence by non-int of type float in our interact function. Okay, so we want to have a look at our error message here and sort of figure out what's happening, right? Don't be spooked by all the large red text, right? You've got to have a bit of a read and try and figure out what's happening here. Self_position times distance. Okay, so it looks like we're trying to do maths with something that's not quite what we think we're having. Okay. Now, looking at what we've got up here. Oh, okay, yep, so we've got one possible problem, right? Here's our distance. Now, input always gives back a string, okay? So if we try and go forward by a string, I imagine that's going to give us some weird problems, okay? So let's just, I guess by default, when we come down here, if our direction is N, we want to make sure that the distance they gave us was a number. Okay, so I am just going to assume they're going to give us a number for now. We'll get into some more error handling stuff in the later things, but for now I'm just going to say, cool, give me a number, otherwise my program won't work. Okay, so let's give it 30, and now let's go north. Oh, my little turtle window didn't pop up. But there, okay, there he is. See, he's gone north. Okay, cool. So we sort of solved a couple of bugs there. Our turtle's going north, and now we're all good. Okay, now we've got a couple of other options here, which are pretty similar, right? Like we've got the east, south, west, all that sort of stuff. So let's get those in. So if the turtle is east, we want to move like that. If the turtle is west, we want to set our heading to be 180. And if the turtle is south, we want to move at 270 degrees. Okay. Now, since our direction can only ever be one of these, right, there's no point of sort of asking all these questions sort of straight up, one after another, right? Because if the direction is an E, it's obviously not going to be an N or a W or an S, right? So there's no reason to always ask all these questions. So let's just chuck in some E-lifts, or L-lifts, however you want to say it. Okay, is it, because this essentially goes, is it an E? And if it's a yes, then Python will save some time by not asking all these other questions, because it went, oh no, this was the right one. No need to go into all of these. Okay, and now the other thing is, so this should work for any sort of direction we give it. So, you know, 50, east. I don't know why the turtle keeps popping up now, but there, okay, so there's our turtle going east, right? Okay, but we wanted this to sort of repeatedly ask our turtle, right? So that way we could start, you know, just keep tapping away and be like, cool, go east, go south, go west, you know, do all of that. So we want to put this in a loop somehow, right? Now, how long does our loop how long is it supposed to go? Repeatedly asks for a direction to move. Okay, so we want our loop to run basically until we get given a cue. Okay, so I guess from here, we just want our loop to run forever. So if we want our loop to run forever, the way the while loop works, right, is we put some sort of condition here. And if every time it gets to this part, the Python basically asks, well, is this condition true or false? And if it's true, it goes into the loop. And if it's false, it doesn't go into the loop, right? So that's like before here when we had I less than num sides. It basically evaluates. It says, well, is I less than num sides? And if it is, it keeps going in, right? So essentially, Python evaluates this condition to a true or false stage. So if we want our while loop to always run, right, we want our condition to always be true. And so we just write the word true, okay? Now remember, everything inside the while loop needs to be indented, okay? For everyone wondering how I just did that sorcery, you can come up here and you can go Format, and there is indent and dedent regions. These guys are really useful. Same with comment, bulk comment. Okay, so these are basically the only shortcuts I know in idle, and I'd highly suggest using them. Okay, but now we should be sort of looping forever. Okay, so let's get our turtle up. Distance 50, north. I don't know why it keeps doing that. Where's my turtle gone? Hello? Okay, there we go. Okay, and it's asking for us another direction. East, south, west, 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 west. Okay, cool, so it's working. And then it always seems to sort of hang here because it's waiting for input, right? And so Windows just assumes that if it's waiting for input that it must be crashing. So let's just exit out of this, close our turtle down, and keep going. So what are the other things we have to do? We have to have a queue, right? We have to finish the interact function when we hit the queue. The turtle window closes and the function ends. Okay, so let's check in here. Elif direction equals queue. I guess in hindsight, direction probably wasn't the best name for this variable. Let's actually go back and change this to, what are we getting? We're getting a command of some sort. Let's go command. And just quickly fix these up. Good variable names are really important because it makes your code just so much more readable, which is useful for getting star marks on the assignment and stuff like that. Okay. So if our command is a queue, right, we want the turtle window to close. So I think there was a turtle command up here for that. Exit and click buy. Buy closes the window. Okay, so turtle.buy should close our window. And then what else was queue supposed to do? And the function ends. Okay, well, whenever we want to end a function, we need a return. So I guess there's our return right there. Okay, so let's just quickly check that. Let's get our turtle up and running. 50, north. Bring up my turtle window again because my turtle is really shy for some reason that I can't quite figure out. Okay, there's the turtle. And east, south. Cool. And now if we put in a Q, cool. And our turtle is done. And we can see that we've got our 3 carrots back, right? So the sort of turtle is finished. And you can see turtle's got some weird stuff, sort of, because it's tried to use turtle.click after a turtle.by. So I told you, this turtle.exit on click thing is a real hassle. But it's still fine, right? And what the other thing we've got here? If the user enters any other input, an error message is printed. Okay, well, I guess we just need an else then, because if we get anything else, right, as long as our command wasn't en and ws or q, then we want to print some sort of error message. What have they got here? That's not a direction. That's not a direction. Okay, so we've got a bit of a problem happening here, right? Our quotes are getting all mixed up because we've got an apostrophe inside our print statement here. So you've got 2 options you can do here, right? One is we could obviously just use the other kind of quotes on the outside, right? Python is completely interchangeable with using the double quotes and the single quotes. But let's say we needed to use both kinds of quotes, right? The other thing we can do is escape this character with a backslash. Okay, so whenever you have a backslash in a string, and it allows you to, it's called escaping the character afterwards. So this quote is now purely acting as like the string character quote, right? It's not an end quote for our string. So you can do this on all sort of special characters. For instance, if you ever want to put a backslash into a string, I think you actually need to use double backslash to escape that backslash. But that's just something nifty to note if you're trying to get around the problem of having multiple quotes inside. Okay, so let's just get our total up one more time. 50, north. Wait for our turtle to stop being so shy. Come on, turtle. Okay, so we've still got control. Cool, and if we type in something that's not a command, that's not a direction, and we can see it's re-prompted us, right? Because it's just gone back to the top of our loop and kept going. South, south, quit. Okay, cool. And we can see that the quit sort of handles itself, right? Because inside our quit, we have returned from our function, right? And once we return from the function, everything is going to end. And so that's how we sort of avoid having this infinite loop problem here, right? Is because this is where we exit out of our function. Okay, and so that can really save us having to sort of deal with a bunch of extra cases and breaking out of our loop and that kind of thing, right? We just return and the function's over. Okay, so yeah, there's our interact. This is sometimes a sort of structure we use for our assignment 1 or 2, right? Sometimes we get you guys to write a bunch of functions, and then we have an interact function where, you know, by inputting different commands, you run some of those previous functions. So maybe that'll come up in assignment 2. I don't know, but either way, it's still good to sort of understand how we can use this flow, this control flow, to sort of set us in several different directions depending on what our input was. Okay. Yeah, cool. And so now what's the last thing we've got here? We've got this challenge guy here, right? Square spirals. Write a function spiral which draws a square spiral with num lines starting from the center, having length side, 2 times side, 2 times side. Okay. So here we got a bit more of a challenge. Gonna try and draw some cool spirals. So spiral, num lines, step, size. Now this is one of the challenge ones, and this is a bit more complicated, so I imagine there's going to be several different ways we can do this. So let's just start off and then see if we can refine our solution later. So what do we want to do? We want our turtle to start, go forward, turn left, go forward, turn left, go forward, turn left. Okay. So essentially we want to go forward, right, by step size. And then we want our turtle to turn left 90 degrees. Cool. So these are the main 2 commands we're going to be doing for the whole thing, right? But we can see we need to know how many times we are sort of increasing this num lines. And we also need to increase this step size as we go. Okay, so we're definitely going to need some sort of loop. And it says that we want to have num lines limes, right? So we want our loop to go num lines times. So I'm going to use that shortcut that I just showed you guys previously for I in range num lines. Okay, so I know now that this loop is going to run num lines number of times. Okay, so let's just make sure we tab our stuff in, and Okay, so what's the example they've got there? 20, 20. So let's just have a quick look and see what this is doing at the moment. Okay, cool. So our guy is sort of just continuously drawing the same square, right? Because we're never increasing our step size. So he's never sort of figuring out that he needs to get further and further away from the center. Okay, so essentially here we've got turtle.forward step size, turtle.left. So I guess what we want, sort of just thinking about it a bit loosely, is we want to do this twice, right? Because we want it to go 2 times. And then we want to increase our step size, right? And so every time we increase step size, we want step size to increase by step size. Okay, cool. So let's set another variable out here. Current step size. And we want that to initially be the same as step size. And then we always want to be increasing by, sorry, always going by our current step size, right? Because now that means that we can increase the current step size by step size, okay? So the reason I did this is because we always want step size to stay constant, right? So we can keep adding it to our, how far our turtle's going. So that's why we need this extra guy here. Okay, so now that we're using him everywhere, we can see that we go twice. So we go forward, left, right? And then we want to increase our step size and keep doing this over and over and over and over again. Okay, so let's see how this is going for now. Okay, so there we go. We can see we're definitely getting the right shape here, right? But he's still going. He's still going. Okay, he's gone way more than 20 now. And it looks like he's actually gone double as many. He's gone 40. Okay, so, well, obviously he's gone 40 actually now, right? Because I'm doing 2 lots of forwards per go, right? So I guess instead of that, we would want to do something like 4 num lines divided by 2. But we don't really want to do that in case we get an odd number, right? Because if we were to give it an odd number of sides and try running this, yeah, you see we get some weird stuff, right? We can't give it a float number, right? We can't give it 10.5. So I guess we would want to do something almost like this. But so that's going to draw our 10 lines, right? I mean our 20 lines. But that's always going to give us 20, right? It's not going to give us 21. So we can see that this is a good start to the problem, right? Like we've managed to get some sort of similar spiral shape going, but it's not really ideal, right? We're not actually sort of perfectly matching because 20 and 21 are going to work the same way. So we want to go a bit back to the drawing board and sort of rework what's happening here. So we definitely don't want to be doing 2 every loop, right? Because if we have an odd number of num lines, we want to make sure that we can always do 1, right? In the, because we would go 2, 2, 2, and then the last one would be on its own, right? And we can't do that with our current structure. So I guess another idea is to think, well, when do I want my step size to increase? Okay, so this line here, right? How often do we want our step size to increase? We want it to increase every second time that it does this forward left thing, right? So depending on what I is, I suppose, we could increase current step size, right? And since we want it to happen every second time, right, we want to be dealing with odds and evens. Now, if you remember from the last week's tutorial, we did discuss a little bit of this guy, the percentage sign, the modular. So if we're going through it and we want to do something on an odd and even time, we can use mod 2 to sort of figure out if we're odd or even, right? Because if our mod 2 is 0, that means that our remainder was 0 and we divided by 2, right? So in other words, we had an even number. So let's suppose that we only want to increase the step size on even numbers, right? So 2, 4, 6, 8. Then we would do, 0, 1. And then we would do 2, 3, 4, 5, all that kind of stuff, right? So we're going in pairs. So let's see how this goes. Okay, so we can see that this was almost right. Yeah, let's see, we've got 20 times, right? And just to be sure, so this guy ended in the bottom left. Let's try chucking a 19 in there. And we'll see if we end up here. Okay, awesome. So our turtle has in fact finished. So we're doing the right number of lines, but we got some sort of weird bump in the middle. I'm actually going to draw that one more time. Yeah, we can see that at the start it's a lot bigger. Okay, so why would that be happening? Our current step size, we started off as step size, and then okay, so here's our problem, right? Let's actually think about what our current step size is. So if our step size starts at 20, our current step size comes in at 20, and then 0 mod 2 is actually going to be 0, right? If we divide 0 by 2, we get no remainder left over. So even before it does the first forward, our step size is going to have increased by this much. So I guess an easy fix to this would just be to set it to be 0 at the start, right? Because that means it comes into the for loop at 0, and then it gets increased by step size, right? And then we go forward and then left. Okay, so let's try that. Okay, there we go. And we can see that, yep, we've got exactly the kind of shape we want going here, and it's doing it an odd number of times, or presumably as well an even number of times. Okay, so there's an example there of how don't be afraid to just start coding, right? Don't be afraid to think about the problem a little bit and be like, okay, well, how do I draw a spiral? And then start off, going 2 at a time, right? If you hit a point where you realize that your solution isn't quite right, then go back and, work from there, right? There's no point sort of just sitting down and being like, oh, I don't know how to do this, right? Always try and work with some sort of idea. Like this here, this isn't even the best solution, probably. I can sort of think of ways that we could use this mod 2 to make this maths a bit cleaner. Actually, I'm going to space this a little bit, but this is certainly a perfectly acceptable solution, right? It's doing exactly what we wanted it to. Okay, so you can also always check out the online solutions we post for this stuff. I'm sure there'll be multiple, probably better solutions for this in Spiral. You could probably do this in maybe 2 or 3 lines, just using a for loop and stepping forward by an increasing amount. So, well, actually, now that I've said that, I'm kind of curious. I'm actually going to try and make another spiral. Let's try and make a spiral in the fewest number of lines that we can. Num lines step size. So what I'm thinking is that essentially we should be able to do this just by using for I in range num lines and turtle.forward and turtle.left. Okay, now our left is always going to be 90, right? Because we're always going to be turning to the left. But our forward here is going to be somewhat based on this step size, right? But we also should be able to do it based on what our I is. Because if we think about it, it increases every second time that I increases, right? So if we were to have our step size, and we want to multiply this by I somehow, but we don't want to multiply, we want it to multiply by I, we want it to increase every second time, right? So for instance, if our I is 0, we want this guy to be 1 that we're multiplying by. But if our I is 2, we also want it to be 1, don't we? We want it to be 2 in that case. So if our I, let's just think of a couple scenarios. If our I is 0 or 1, we want it to be 1. If our I is 2 or 3, we want it to be 2, because we'll have increased our step size by 2. So what I'm thinking is that we can actually use our floor division here, okay? Because we want it to be every second time it increases, and we don't have to deal with odds and, halving an odd number and getting a 0.5. So let's just try this. Okay, so how many times was that? That was 20 times. 1, 2, 3, 4, 5. Oh, wait. I've just called my other function. I was like, wait a minute. Spiral 2. Okay, so this guy sort of face started backwards a little bit, and he's drawn 2 less lines. So it looks like our math was 1 off. Let's just run that one more time and see what he does at the beginning. Yeah, so I'm not sure if you saw that, but the turtle sort of zigzagged around on the spot for a bit. So that probably means that our distance at the start was 1 smaller than it should have been, right? So we were moving forward 0. So if we think about it, 0 mod 2 is 0, right? So we would have 0 times the step size. So that's not what we want. We were 1 off. So I guess we would just want to increase this guy by 1. So that we have step size. Yep, cool. Yeah, there we go. So we can see it's going the right way, right? It's going right and then up first. And then we've drawn our 20 lines. Cool, exactly like the picture now. Okay, so I think that's a really fun little exercise you can do with some of these problems, right? Particularly when you get your head around them and you know what's doing. Try and reduce the lines of code you have, right? obviously this quite here is still a very good solution. It's very readable. This is a bit shorter, and this would probably need some sort of commenting to sort of figure out exactly how this works, right? So these are two probably both equally good solutions. They just sort of favor different things, right? So I would definitely encourage you to try and play around and, you know, make your code shorter, more efficient. It's a little thing we call code golfing sometimes, is trying to write a solution to a problem in the fewest lines or the fewest number of characters. Okay. But otherwise, this has been the week 3 tutorial solution video. And as always, if you guys have any questions, drop them in the comments section. I'm going to try and release these videos a bit more on time. These first few have come out a bit late, but I should generally try and get them out over the weekend after the tutorial, same as when the tutorial solutions come out. And yeah, if you've got any questions, you can also always post on our discussion forum on Piazza. Okay. Otherwise, good job following along with the solutions, and I will see you guys next week.